Hello and welcome to this solution video of paper 4 mechanics A and AS level mathematics Cambridge International Examinations. This solution is of October-November 2022, which was written just 3 days ago. Many people were demanding that I should upload solutions. I can upload the solution only the ones which my students write. So this was written, so it was available. I'm solving this for you. Okay, let's move on to question number 1 straight away. A cyclist is riding a bicycle along a straight horizontal road AB of length 50 meters. So let's draw this. This is A, this is B, and the length is 50 meters. The cyclist starts from rest, that means U is 0 at A here, and reaches a speed of 6 meters per second at B. V is 6 meters per second. The cyclist produces a constant driving force of 100 newtons. So if I draw a free body diagram, the forward force, which is also called applied force, is 100 newtons. There is a resistance force, that means there will be a resistive force, let's call it Fr, in opposite direction. The work done against the resistance force from A to B is 3650. So work done by resistive force is 3560. Find the total mass of the cyclist and the bicycle together. Since work is involved, let's use the normal energy equation, where work done by applied force is equal to the sum of work done by resistive force plus change in potential energy plus change in kinetic energy. Okay, work done by applied force, work is force multiplied by the distance. In this case it is 50. So force applied is 100 newtons multiplied by distance, which is 50. Work done by resistive force is given 3560. They clearly said it's a straight horizontal road. That means there is no change in potential energy. It remains at the same height. Kinetic energy change will be half. Let me write the formula here. For kinetic energy is half m final velocity minus initial velocity, and that's what we'll do. M is, we have to find m. Okay, final velocity is 6 meters per second minus U is 0. Okay, so it is 5000 equal, let's bring this to the left side. So 3560 is negative now, equal to half m times 36. We can cancel this here, 18. All right, so now 5000 minus 3560 will be 1440 equal to 18 m. Divide both sides by 18. So cancels here, and 18 times 8 is 144. So m becomes 80 kilogram. This mass of cyclist and its cycle is 80 kilograms. Okay, question number 2, A part. A particle P of mass 0.4 kg is in limiting equilibrium on a plane inclined at 30 degree to the horizontal. So let me draw it here. This angle is 30 degrees. Okay, the mass is 0.4 kg. That means the weight will be 0.4 times 10. 4 Newton will be the weight towards the ground. And it is in limiting equilibrium. The component of this weight in this direction is always the sine component. So it will be 4 sine 30 degrees. Okay, is it smooth? It is not smooth. Okay, show that the coefficient of friction, that means there is friction also, coefficient of friction of the particle is this. Whenever this is show that, it makes our job very easy. Our target is known to us. We have to reach here. And the frictional force will be in this direction, right? Frictional force is the coefficient of friction that they are asking, mu times the normal contact force R. Normal contact force is, normal means 90 degree to the surface in this direction, and it is always, not always, mostly equal to this component which is in this direction, because they are balancing it out. There is no other force, that's why they are balancing out. This component of 4 Newton is 4 cos 30 degrees. This is sine 30, this is cos 30. That is, this 4 Newton has been broken into two components. Alright. Since it is in limiting equilibrium, that means this force 4 sine 30 will be equal to frictional force in this direction. That's why it is not moving, which is mu R. Mu we have to find, and R we just found. R is 4 cos 30 degrees because they are balancing out. So I will write here 4 cos 30. Now you can use your calculator to evaluate these. Sine 30 is half. So 4 times half equal to mu times 4 cos 30 is square root 3/2. Okay, so this cancels, this also cancels. So 2 equal to mu 2 square root 3. We want to isolate mu. So 2 square root 3 divides both sides. Here it cancels fully, here it cancels partially, only 2 and 2 cancels. So mu comes out to be 1 over square root 3, but it is not matching with what they want. For that, we will rationalize the denominator, multiply by square root 3 up and down. Square root 3 times 1 is square root 3. Square root 3 times square root 3 is complete 3, and now we got what they wanted, which is 1 over 3 square root 3, same thing as this. Okay. A magnitude of 7.2 Newton is now applied to P directly up the line of greatest slope. So let me go back to this, and there is a the diagram will change now, so I'll have to redraw this, because friction joins the weaker force. So if we are applying 7.2 newtons upwards, and given that P starts from rest, that means it starts moving up. When the body starts moving up, friction cannot be in upward direction, it has to go in this direction now. So there are two forces here now, frictional force plus 4 sine 30, which is 2 Newton. We already, let me write 4 sine 30, if for the sake of understanding. If you sometimes skip the video, maybe you're not aware why it came here. All right. So there are two forces now, and 7.2 in this direction, and everything else remains same. No need to show it. Okay. Find the time it takes for P to move up 1 meter. So S is 1 meter. They are asking us time. If somehow I find acceleration, I will get that time. For that, I should do what? I should equate these two, and we'll get the net force out of it. F net force is equal to mass times acceleration, right? And here this 7.2 is still stronger than these two forces, so it will become 7.2 minus F. We got this thing, yeah, this was square root 3 over 3, right? That was mu. So F I will write as mu R. So square root 3 over 3 R. R was how much? 4 cos 30. 4 cos 30 is a square root 3 over 2. All right, this F is done. 4 sine 30 plus 4 sine 30. Sine 30 is half. So let me again write the value of half. So what I did, 7.2 is in this direction and motion is also in this direction, so I took it as positive, and the two forces which are opposite to it, which is F and 4 sine 30, with their negative, so I put a negative outside and added them inside a bracket. And they've given the mass. Yes, mass is given in the first part. Let's see. Yeah, 0.4 kg is the mass. So let's use it. 0.4 times A is equal to 7.2 minus this complete 3 will cancel with these square root 3's because they are also complete 3 together, right? So I can cancel this. This 2 cancels with 4. So 2 plus, they are also cancelling, 2 plus 2. So 0.4 A is equal to 3.2. If you are not aware how this happened, please just put in a calculator, you will get the same answer. 7.2 minus 4 will be 3.2. So A is 3.2 divided by 0.4, which is 8. Yeah, 8 meters per second square. Now we got acceleration and we can find the time now. Acceleration is 8 meters per second square. So what do they want? They want time it takes to go 1 meter up. Okay, and it starts from rest, right? It starts from rest. So U is 0. So we can use S equal to UT plus half AT square. This kinematic equation we can use. S is 1 meter, U is 0 times T plus half. Acceleration now we got 8 and T square. So 1 equal to 2 and 8 cancel, 4T square. Divide both sides by 4. So T square is 1 over 4, and if we square root both sides, T will be plus or minus half, but because time cannot be negative, so only half second. This is the time taken by that particle object to go up 1 meter. Okay. Question number 3. Question number 3 has this setup. A particle of mass 0.3 kg. Let me draw it here. The weight of this 0.3 kg will be 3 newtons, right? 0.3 multiplied by 10 is held at rest by 2 light inextensible strings. This is string, this is one string. One string is attached to the ceiling at 60 degrees. Okay, it's there. The other string is attached at an angle alpha to the vertical wall, and the tension in the string is attached to this 4 newtons. So here we have a tension of 4 newton. Find the tension in the string which is attached to the wall and find the value of alpha. Okay, so let's focus on this mass whose body diagram I started to draw. There is a tension in this direction which we have to find. Correct? This tension in this string. There is a tension in this direction also, which is, how much they said? 4 Newton. It is 4 Newton in this direction. Any other force? No. The weight and 2 tension, they are the only forces here. But only this weight is vertical, others are inclined. So we should change them to their components. First of all, this alpha angle. Let me draw here in the drawing diagram itself, you'll understand. If I draw a line, vertical line, don't you think this angle and this angle both are alternate angles because this line is parallel to wall. So this angle becomes alpha for us. Okay. Similarly, this is 60 degree. So if I draw a horizontal line, this angle will also be 60 degrees because they are also alternate, and this horizontal line is parallel to the ceiling. That's why it is 60 degrees. So I will draw a horizontal line too and write that this is 60 degrees. These two lines, this horizontal line and this vertical line, will help us to divide this T and 4 into their components. whichever component has an angle with the force becomes the cos component. So this downwards component of T will be T cos alpha. The component on the opposite side of the force here will be T sin alpha. That's the rule. I have explained this in my previous videos as well. Now, here is the angle. So this will become 4 cos 60. Cos component again, because the angle is here. The opposite one, 4 sin 60 degrees. Right? Now we have all of them and we can form equations out of this. So first, let's equate the horizontal forces. Horizontal force is 4 cos 60 towards left and T sin alpha towards right. So T sin alpha equal to 4 cos 60. Cos 60 is half. So T sin alpha equal to 4 times half, which is 2. This is equation number 1. Let's talk about equation number 2, where we will compare the vertical forces. So 4 sin 60 and this T cos alpha, which is downwards, plus 3 Newton, which is also downwards, will be equal to 4 sin 60. Let's keep T cos alpha here and bring 3 there. So it becomes 4 sin 60 is square root 3 over 2, and then this plus 3 goes there and becomes minus 3. Okay, so this cancels also. So T cos alpha, if I use my calculator, T cos alpha becomes how much? 2 square root 3 minus 3. Let's not use calculator, just 2 square root 3 minus 3. I will use calculator later. This equals equation number 2. So whenever we have a combination of force and its angle, just divide the sine 1 by the cos 1. What I mean is this: if I divide equation number 1 by equation number 2, not in opposite direction, why? I will tell you just now. T sin alpha is the left side here, equal to 2, divided by T cos alpha, which is left side here, divided by 2 square root 3 minus 3. So the purpose is T and T cancel, and sine over cos, we know that it is tan alpha, it becomes 1 ratio. That's why we divide sine by cos, not cos by sine, because there is no cot in our calculators. So 2 over 2 square root 3 minus 3. So alpha we can find. They are asking us to find alpha, right? So they are asking tension first, but we are finding alpha first. That's fine, no problem. Tan inverse 2 divided by 2 square root 3 minus 3. And by the time I use my calculator to evaluate this, I would request you to appreciate that I'm solving this exam very quick and helping you to understand your mistakes and prepare for future exams also. When I put this in my calculator, I get 76.9 degrees and 3 significant figures. That's fine. Now second part was to find tension as well. Find the tension in the string attached to the wall, and we have an equation for that, which is let's use this one. So T sine, and now we know alpha is 76.9 degrees is equal to 2. So divide both sides by sine 76.9 degrees and sine 76.9 degrees, so that this cancels here. T is equal to 2 divided by sine 76.9, which is 2.05 Newton. We got tension as well as the angle. All right, move on to question number 4. A car of mass 1200 kg is traveling along a straight horizontal road AB again. They have similar situations. A, B. There is a constant resistance force of magnitude 500 newtons. So resistive force is there, which is 500 Newton. When the car passes point A, it has a speed of 15 meters per second. At this particular point, U is 15 meters per second. And the acceleration is 0.8. And they're saying when the car passes point A, this acceleration is here. It is not throughout the journey. It is here at this point. Okay. Find power of car's engine at point A. At point A. That means not after this, at point A only. All right. So in this case, they have given us a resistive force. They have given us the speed and this. So power, they are asking power, right? Power is at a specific point, whatever is the force which is being applied by the engine or the person times the speed at that point. Okay, this becomes power. Speed is known to us, 15, and okay, that's it. And applied force, we don't know, they have not given, right? Now, since acceleration is known, we can use the formula we used earlier. F net is equal to ma, which is the forward force or applied force minus the resistive force, right? M is known to us, which is 1200. Acceleration is also known to us, 0.8. At that point, applied force, we are on the way to find out, but we know resistive force 500 newtons. 12 times 8 is 96, so 960 Newton is equal to F applied minus 500. Let's bring this 500 to the left side. So 960 plus 500 is equal to applied force, which is 1460 newtons. And this is what we will use here. So it becomes 1460 multiplied by velocity, which is 15. And if I multiply, it becomes 21,900 watts, or you can write 21.9 kilowatts. Okay, what about B part? B part says the car continues to work with this power even after that. So if the power remains same, this power remains same, and applied force and velocity will change, because we know the velocity will increase to this, and they have written here speed of the car at B is 32. So speed here is 32. That means speed is increasing, but the power is remaining same. That means force applied is reducing because velocity is going up. Okay, this is how we interpret the situation. The car takes 53 seconds to travel from A to B. So time is given to us. Time is 53 seconds. Okay, and velocity, last velocity is 32 meters per second. Show that the distance AB is 1362.6. Okay, so let's do what? Let's use the energy formula again. Okay, so first we have to find work done. We know work applied is resistive work done by resistive force, and plus change in potential energy plus change in kinetic energy. We don't know what is the work done by applied force, but we know that the power is the work done by time. Yeah, at the rate time is work is done is called power. So we can find that applied work with the help of this, because we know power, which is 21,900 from part 1, equal to this over 53. So this goes and multiplies here. So applied work is 21900 times 53, which will be 1160,700. And that's what we're going to do here. 116,070 is applied work. Resistive work done by the resistive force will be, how much was the resistive force? 500 and multiplied by distance. Yeah, let me remind you again, work is force done multiplied by the distance traveled by the object. So force times distance. So this distance they're asking us to show that is this. Again, it's a horizontal road. Let me see again and show it to you. Straight horizontal road AB. That means the height is not changing again in this question as well. So it will be 0. But speed changed to 32 meters per second from 15 meters per second. Yeah. So if you remember, we have done in previous question number 1, I think, delta KE is half m v square minus u square. So half m, and the mass is how much? 1200. Yeah, yes, 1200 is the mass. So times 1200, 32 square minus 15 square. Done everything known except for the distance. So 116,070 equal to 500 d. 2 multiplies here, 600. 1024 minus 225 will be 799. Oh, sorry, it is not plus, it's multiplying. This 600 will multiply with this, so 799. So let's keep 500d here and bring this whole thing to the right side. So 116,070. Oh, there are 2 zeros. Okay, I forgot to transfer it well. Minus let me 479,400 equal to 5d. Divide both sides by 500. So that is cancels and we get distance, and I'm sure the distance will be 1362.6. Moving on to question number 5. A block A of mass 80 kilograms connected to a light inextensible rope to a block B. So this is a rope they are connected with, and block B is of 40 kg mass. The rope joining the 2 blocks is taut, okay, and is parallel to the line of greatest slope, this one, which is inclined at 20 degrees to the horizontal. A force of magnitude 500 Newton is inclined at 15 degrees above the line of greatest slope, acts on A, okay. The block moves up, this is important, moves up the plane, and there is a resistance. Okay, since the block is moving up, there will be a resistance which could be friction or the air resistance, but they have combined both on B but no resistance on A. This is interesting. We have hardly seen such an example where one block will have some resistance but the other will not. Oh, that is interesting. Okay, anyways, if they say so, we'll accept it. Find the acceleration of the blocks and the tension in the rope. Since they are asking acceleration of the block first, we will consider the whole as one body. So we will draw a free body diagram as if they are moving together and they are acting as one entity. So let me redraw this. First, this 80 kg mass, its weight downwards will be 800 newtons. The one which is down there will have a weight of 400 newtons, right? 40 times 10, 400 newton. The component of 400 newton downwards will be 400 sine 20. And this will be 800 sine 20. Now, they have tension in between also, so T here. But when we consider the whole as a system, tension becomes part of it. So the tension this way and tension this way cancel out each other. So tension is not included if the whole system is taken as one. Let's talk about the force which is at 15 degrees angle, which is a 500 newtons, right? We have 500 newtons. So 500 newtons this way. Since this system is not moving in this direction, that means we need to write the component of this in this direction. Since the angle here is 15 degrees, wherever is the angle, that is cos. So 500 cos 15 degrees. There will be one component here as well, which will be 500 sine 15 degrees. However, they're saying there is no resistance on A. There is only on B. So I'm ignoring 500 sine 15 because that means there is no friction as well. This would have a role in frictional force. Since there is no resistance on this, so that means this normal contact force can be ignored, and I'm ignoring it as if it does not exist. So there is one additional 50 Newton force on B which is against the motion. That means this 50 Newton will add up to this 400 sine 20. These are the all forces. This question is worth 5 marks and mostly for labeling the forces. So now, since the thing is moving in this line of greatest slope, we will find the difference of those forces only. Others are just forces. Okay. So in this whole system, what is the applied force? F net is MA, which is applied force, which is forward force minus the resistive force. The force which is going forward is only one force, which is 500 cos 50. Yeah. So in place of this, we will write 500 cos 15 degrees. This 800 sine 20 is in opposite direction. So we will write minus 800 sine 20. This 50 is also in opposite direction. This 400 sine 20 is also in opposite direction. So let's combine all of them together. We will add all of them and then subtract, add minus to them. So 400 sine 20. Three forces opposite this 500 cos 15. Anything else? Nothing else. This will be equal to MA. M will be 120. 80 plus 40. There are two masses which are moving, right? Even though force is on 80 kg only, but it is carrying along 40 kilogram, and we are treating both of them as one whole system, and tension is ignored because it is part of the system, and times acceleration. So simply our acceleration, if I divide this by 120 and divide this whole by 120, this 120 and 120 cancel, and we get an acceleration. If we do carefully enter everything in our calculator, we will get acceleration. By the time I do this with my calculator, I would request you to please like this video, give it a thumbs up, and share this with your friends so that more and more people get benefited. They understand what are the mistakes they're making, and subscribe to my channel. That will motivate me to make many more videos like this. Thank you so much. What I'm getting here is 0.187822. Since we want three significant figures, so we will write 0.188 meters per second square. This is the acceleration. Now they are also asking the tension in the rope. For tension, we should focus on one of the bodies, either A or B. And I'll prefer B because it has less number of forces. So I'll take this as one system, and I will find tension according to this. So the body is moving upwards, right? That means the force upwards is stronger. And what is the force upwards on this body? Tension is the force which is upwards. So in place of force applied, we will use tension in this case. So MA equal to T. minus, what are the opposing forces? These two, 400 sine 20 and 50 newtons, which is the resistive force. And what are we looking for? We are looking for tension. So let's keep tension on the right side and bring this negative also to the other side. So M is how much? 40 kg in this case, because we are focusing on only B, not A. So 40. Acceleration is known to us 0. Okay, let me write this big one because I want to be as close as possible. 18722, right? And equal to, not equal to is already there. So plus this 400 sine 20 plus 50. 400 sine 20 comes out to be 136.8 plus 50. And if I add all of them, tension comes out to be 194.318 to 3 second figures, 194 newtons. That's the tension in the rope connecting two bodies. Let's move on to B part of this, which says find the time it takes for the blocks to reach a speed of 1.2 meters from rest. Since the acceleration is constant, we can use kinematic equations, and in this case find the time they are saying V equal to U plus AT. That's what we can use. V is 1.2, they want to reach at. U initial is rest. So 0 plus acceleration is 0.1872822. Okay, and time they want to find out. So divide, this is 0, so gone, and we can divide it by 0.187822 divided by 0.187822. So the time comes out to be, if I divide this, I get 6.388999. So 6.388999, and obviously we have to round off to 3 significant figures. So it will be 6.39 seconds it will take to reach a speed of 1.2 meters per second. Moving on to question number 6. The three particles A, B and C of masses 0.3, 0.4 mkg respectively lie at rest in a straight line. Okay, so let's represent them by balls. They are going to collide later on. Okay, so this is A, this is B and this is C. The distance between B and C is 2.1. So from here till here, the distance is 2.1 meters. Practically, this is the distance, okay, this one. But for the simplicity's sake, I drew it like this. Okay. A is projected directly towards B with this speed. So this is projected. That means its initial velocity is 2 meters per second. Are the surfaces smooth? Straight line, smooth, yes. They can see a smooth horizontal plane. That means when it reaches near B, its speed remains 2 meters per second, because by Newton's first law, there is no force which will apply on it on backwards, so it will reach here 2 meters per second. All right. After A collides with B, the speed of A is reduced to 0.6. All right. So let's say that U of A was 2 meters per second. Initial velocity of B was rest. Final velocity of A is 0.6 meter per second, and they are asking show that the speed of B after collision is this. So UB we have to show. That means we can't use it. We can't use this one. We have to arrive at this answer. So we can use conservation of momentum. So according to conservation of momentum, the mass of A multiplied by the initial velocity of A then mass of B multiplied by initial velocity of B will be equal to mass of A, final velocity of A, plus mass of B multiplied by final velocity of B. Okay, and now let's substitute everything and we'll find VB. Yeah, they are asking VB. So MA is mass of A 0.3 and speed is 2 plus mass is 0.4 for B, but it is at rest, equal to mass remains 0.3, there is no change in conservation of momentum, velocity reduced to 0.6 and mass is 0.4 and we have to find VB, final velocity of B. Everything is known to us. This is 0, so it is gone. 0.3 times 2 is 0.6 minus, this will go to the left and become minus 0.18, 0.3 times 0.6 equal to 0.4 VB. So let's finish it here. 0.6 minus 0.18 will be 0.42 and equal to 0.4 VB. Divide both sides, 0.4 and 0.4. Cancel here, VB comes out to be 0.42 divided by 0.4, definitely 1.05 meters per second. That's what they were asking us to show. Let's go to the another part of this. After collision, what happens that A and B moves directly towards C. So B starts moving towards C with what speed? 1.05. So not 10.5, 1.05. And because velocity of A after collision is 0.6, that's what we use, right? 0.6, that is, it is following back. 0.6, it is following, this is B, this is A, right? But since B is faster, 0.6 will not catch up, so B will collide with C. Let's see, particle B now collides with C. See, they are saying here. After the collision, the two particles coalesce, means they become one body and have a combined speed of 0.5. Okay, find M. So nothing different, only that this conservation of momentum, this particular equation will change. What will that be? It will be MB now and UB plus MC and UC equal to, since they coalesce means they become same body, so MB and MC become one body and they have one final velocity, the no B, no C. Both of them move together. Alright, so MB is 0.4, its velocity we got 1.05 plus MC is M, we don't know its mass, but we know that it was also at rest, equal to 0.4 plus M and their combined velocity is 0.5, that is the final velocity. So this is 0.4 times 1.05 will be 0.42 again. Okay, equal to 0.4, let's open this bracket. 0.4 times 0.5 will be 0.2 plus M times 0.5 will be 0.5 M. Let's bring this 2 to the left. So 0.42 minus 0.2 equal to 0.5 M 0.22 equal to 0.5 M. Divide both sides again to get rid of 0.5 here. 0.44 kg is the mass of C, because M was the mass of C, that's why that is the mass, 0.44 kg. Okay, do we have a third part? Yes, we have. What does that say? That says find the time it takes for from the instant when B and C collide Okay, let me redraw the situation here. So we said that B and C collides, right? And we know that A is still coming towards the both of them with a speed of what? 0.6 meters per second, and they are moving with 0.5 meters per second now. That's what in B part they said. That means this is faster now. So what happens? Until A collides with the combined particle, until A goes and collides with them, right? This is what they're saying, a total time taken. So first of all, we should know how much time was the time between the collision between A and B and then B and C, because A was moving still after that, isn't it? So the distance between the two was 2 point something, 2.1 meters. 2.1 meter was the distance between B and C. So the collision happened here and then B and C collided here. So B traveled 2.1 meters to meet C. So what was the speed of B? B was 1.05, right? Okay. The time taken by B to collide with C. Even though they're asking us about after the time when B and C collided, but we want to know how much distance A traveled till that period. Okay, and that's why I'm trying to find that time. So the speed time equal to distance over speed. Time. Distance was 2.1 meters. Speed of B was 1.05, and if I divide it becomes 2 seconds. Right? So the distance traveled by A for 2 seconds, because it was still moving in the direction of B and C. So in those 2 seconds, how much distance does A travel? So distance equal to speed times time. And speed of A was 0.6 times 2 seconds, 1.2 meters. So let's visualize this. When A was coming here, the distance from this point of collision of A and BC here was 2.1 meters. When they collided, after 2 seconds, A had traveled 1.2 meters, 1.2 meters. That means it was 0.9 meters away from the point of collision of B and C when they collided. 0.9. How did I get 0.9? 2.1 minus 1.2 is 0.9. This is 0.9 A need to cover. Yeah, it has to cover because the distance between them is 0.9. Now this 0.9 A has to cover. The distance to be covered by A to collide with B and C will be 2.1 minus 1.2, 0.9 meters. Right? Now, how will that cover? By the difference they have between their speeds. So difference between speeds of A and BC. BC is one body, A is one body. Since there is no resistance, that means A will keep on moving with the speed it was moving, 0.6 meters per second, and they will keep on moving with the speed of 0.5 meters per second. So the difference is 0.6 minus 0.5, which is 0.1 meters per second. Okay, and again now we have to cover 0.9 meters with this difference. So the time equal to distance over speed. And distance is the difference in their positions, and speed is the difference in their speeds. So 0.9 divided by 0.1 equal to 9 seconds. This is the time after the collision of B and C. A will catch up and collide with them again. Okay. Question number 7, hopefully the last question. A particle P travels in a straight line starting at rest from a point O. Okay, so this is point O and it is going starting from rest. So V is 0 here. Of course, time is 0. It is starting from here. This is the relationship. That's what this line means. Starting from rest from point O. This is how we interpret this. The acceleration of P at the time t seconds after leaving O is denoted by this. So it has from 0 to 4 seconds. This is the equation. From 4 to some other t seconds, this one is the equation where k and t are constants. Find the velocity of P at t equal to 4. So at t equal to 4, I can use this or use this, does not matter, but since it is equal sign here, I will prefer to use the first equation. But the problem is we have acceleration equation here, so we have to convert this into velocity. So velocity is the integration of acceleration, which will be the integration of 0.3 t to the power half. So V equal to 0.3 is constant, keep it safe, t to the power 1 over 2 plus 1 divided by 1 over 2 plus 1 over 2 plus 1 plus C. So V becomes 0.3 t to the power 3 over 2 over 3, and I'm not writing over 2 here, I'm multiplying 2 with the numerator, because denominator of a denominator can be written as a numerator. Okay, so I can cancel, plus C is also there, right? So I can cancel 0.3 is 10 and 2 divided by 10 is 0.2. So V is 0.2 t to the power 3 over 2 plus C. Before I can use this, I have to evaluate C, and this situation will help me to evaluate C. When t was 0, V was 0, so I will substitute it here. 0 equal to 0.2 and time is 0, 3 over 2 plus C. So this is 0, this is 0, C is 0. So C is insignificant here. Our equation remains V equal to 0.2 t to the power 3 over 2. And now they are saying what is this velocity at t equal to 4? At t equal to 4, V equal to 0.2 times 4, 3 over 2, 0.2 times, this will be 8 times 0.2, 1.6 meters per second. That is the velocity at t equal to 4. All right, what is B part? It is given that there is no change in velocity at P at t equal to 4. That means the velocity will remain same at this 4 also. Obviously, this is a physical body. Physical body suddenly does not change their velocity. So velocity at P remains 1.6 meter per second. That let me write here. V at t equal to 4 is 1.6 meters per second. That's what this line means. And that the velocity of P at t equal to 16. At t equal to 16, V is 0.3 meters per second. That's what they're saying. Show that k is 2.6 and find an expression in terms of t for the velocity of P in this. So what was the equation from 4 to capital T? minus k t to the power minus 3 over 2. So v will be integration of acceleration again, which is minus or positive minus k t to the power minus 3 over 2 dt. So let me integrate this. V equal to minus k remains minus k t to the power minus 3 over 2 plus 1 over minus 3 over 2 plus 1, just like we did earlier, plus c. V is minus k t to the power minus 3 over 2 plus 1 is minus half over minus half minus 1, and I write 2 here. This they're not subtracting, right? So this negative and this negative, this will confuse you. So let me write 2 not here. I will write it here. So now negative and negative cancel. So V is equal to k, 2 can be written here, k t to the power minus half, and that was plus c. Again we have to find plus c first, then we can find k. Yeah, we have to show that k is 2.6, but first we have to find c, and this situation will help us to find t equal to 4, v is 1.6. So at t equal to 4, v is 1.6, and that's what I'm going to use here. 2k t is 4 to the power minus half plus c. So we have two constants here. We have to evaluate them, but let's see. Yes, it can be an equation. 1.6 equal to 4 to the power minus half is 1 over 2, and that 2 can, they are exactly same. 2 and 1 over 2 cancel out, so k plus c. Okay, let's get one more equation. And how will we get that equation? We'll get equation with this situation. At t equal to 16, v is 0.3 meters per second, and same equation I will use, which is 0.3 equal to 2k. T is 16 to the power minus half plus c. So 0.3 equal to 16 to the power minus half will be 1 over square root 16, which is 4. So k over 4, right? 2 times 2. K over 2 plus c. Okay, you can use your calculator. This will be the one. So now we have two equations here. Let's subtract one from the other. Let me have some space here. Subtract this one from here. So minus 0.3 equal to half k plus c. So subtraction, c and c will cancel out. K minus half will be half k, and 1.6 times minus 0.3 will be 1.3. And if I complete it here, multiply by 2, so that this 2 and this 2 cancel, and clearly k is 2.6. This is what we were to show. Okay, let's see what is c part. Now, given that p comes to instantaneous rest at t equal to t, so let me use this space. At t equal to capital T, v is 0. Find the exact value of t, and this t, second equation is applicable. If you look at this equation is applicable to capital T, and for that we already have an equation. Where is the equation? Equation is this one, right? But in problem is we don't know c here, so let's evaluate c somewhere else. Let me evaluate here. So v was 2k t to the power minus half plus c. Rather, I got an equation already. I got this one, right? 1.6 equal to k plus c. Yeah, I will use this one. So 1.6 equal to K plus C. So 1.6 minus 2.6 equal to C. So C is minus 1. Got it. The equation now becomes, this equation becomes V equal to 2.6 t to the power minus half minus 1, because C is minus 1 now and I replaced it. Now at t, V is 0, and we will substitute these two facts now. V is 0, 2 times 2.6, 5.2 t to the power minus half minus 1. Let's bring this minus 1 to the left. 1 equal to 5.2 t to the power minus half. Let's cross multiply. So 1 over 5.2. Yeah, this is a numerator, it becomes denominator other side. And to make this negative positive, this will also become a denominator. And both are reciprocals, so reciprocate. Procate both sides. What do they give me? 5.2 equal to t to the power half is square root t, right? So, or let me write half only. Why should do? If we have not done it till now, why should I do it now? So t to the power half and square both sides to get t, and that gives me t equal to square of 5.2 is 27 point something something. Let me see, 27.04 seconds. This is the value of capital T. Do we have another part? Yes, we have. Find the total distance traveled from t equal to 0 to t equal to capital T. Wow. That means we will have to integrate both the situations. So let's write here 0 and t is equal to 4, and then 4 here t is equal to 27.04. This is what we got just now, 27.04 seconds. Before integrating, let's ensure that there is no turning point between these times. If there is any, then there will be a problem. So let me hurriedly confirm that. Our equation for velocity from 0 to 4 was this. Yeah, this was the equation. Let's make it equal to 0. So 0 equal to 0.2 t to the power 3 over 2. This will give us a stationary point, a turning point. So divide by 0.2, 0.2. So t to the power 3 over 2 is 0, so t is 0. The turning point is at time equal to 0, which is useless because 0 is at the starting point, so that's fine. There is no turning point from 0 to 4 with this acceleration equation. Let's see for the other one. Okay, here it is. This one, 2.6 t to the power minus half minus 1. Let's see if it is equal to 0. 2.6 t to the power minus half minus 1 equal to 0. So 5.2 t to the power minus half equal to 1. So it becomes 5.2 over t to the power half equal to 1. Cross multiply. So we know that if I square this and square this, I got already 27.04. That means there is no turning point between 4 and 27.4. Also, this part is also without any turning point. So we just straight away find the distance. All right. Now, for this, we'll have to integrate the equation of velocity we got in first part, which was this. V equal to 0.2 t to the power 3 over 2. This was velocity equation. C came out to be 0, and that's why we will use it. 0.2 t to the power 3 over 2. Okay, but they want distance. Distance is S. S is integration of t, which was 0.2 t to the power 3 over 2. dt. So it comes out to be s is 0.2 t to the power 3 over 2 plus 1 over 3 over 2 plus 1 plus c. Okay, so what do we get here? S equal to 0.2 t to the power 5 over 2 over 5 multiplied by 2. Let's make some space for this. Okay, so plus c. Now we have to find this from 0 till 4 seconds, right? So I'll continue here. S equal to, I'll substitute this for here. First is 2 times 0.2 is 0.4 over 5, and then we have t 4 to the power 5 over 2 plus c minus, I'll substitute 0, but okay, let me write it, 0.4 over 5, 0 to the power 5 over 2 plus c. This c and this c cancels, this is 0, so this is wholly cancelled. This is the only thing which will give us the distance traveled in first 4 seconds. What will that be? 0.4 over 5 and 4 to the power 5 over 2 is 32, and it comes out to be 2.56 meters. Now we have to move on to the second one. The equation for this one was, we can write this one, 5.2, where was it? Okay, I can use this one. So I have to integrate s equal to v dt again. That means we have to integrate this one, 5.2 t to the power minus half minus 1 dt. So s equal to 5.2 remains 5.2 t to the power minus half plus 1 minus half plus 1 minus, the integration of minus 1 will be t, and then we'll have a constant c. Okay, s equal to 5.2 t to the power minus half plus 1, positive half, and positive half here also, 1 over 2 minus t plus c. And this we have to find distance from 4 to 27.04, correct? And this is what will continue here. So 2 times 5.2 is 10.4, t 27.04 to the power half, basically square root of this one, okay, minus 27.04 plus c minus, we substitute 4 into this, 10.4, 4 to the power half minus 4 plus c. First thing first, cancel out c. Many people don't write c, but I have a habit of writing it so that we understand why do we not write c, because it gets cancelled out. Okay, so 10.4 and square root of 27.4 we already knew earlier, 5.2, yeah. So 10.4 times 5.2 minus 27.04 minus 4 to the power half, which is square root of 4, which is 2, 20.8, and this negative will make it positive and plus 4. Okay, so this will be 54.08 minus 27.04 minus 20.8 plus 4. Use your calculator to find this. What I'm getting is 10.24 meters. Look at the question, what they say. Find the total distance traveled between t equal to 0 and t equal to capital T from t to 0, t equal to 0 to 4. This was the distance. From 4 to 27.4, which was capital T, was this. So now we will write total distance traveled is 2.56 plus 10.24, which comes out to be 12.8 meters. And that concludes this solution video, which has been first of its kind in the whole world. I hope you liked it. If you did, please give it a thumbs up, and it will be awesome if you subscribe to my channel and share this video with your friends and spread the word. Thank you so much.